Okay, so 8C, we're talking about factorial notation. Now, this will be the funniest joke you'll hear today. Alright, this number here, it's not 3, it's 3. Alright, and what that means, whenever we have an explanation after it, we call that a factorial. And so that means every integer up to 3, 1 times 2 times 3. Okay? If we have 4 factorial, 1 times 2 times 3 times 4. Alright, so you can see 1 times 2 times 3, that's going to be 6. And 1 times 2 times 3 times 4, that would be 24. Alright, 2 times 3, 6. 6 times 4, 24, etc. Keeps going on. Alright, so it's just introducing you to that notation. Factorial notation. That's 8C. Then we'll move on to 8D, where we're talking about combinations. Okay, now these are very subtly different from permutations in that they don't depend on the order. Okay, they don't depend on the order. And so it's useful, for instance, like the example we've got here, 10 candidates for school captain, regardless of sex. So if you have 10 people going for school captain, like it's not like you have the order, it depends on the order of them. Okay, so at the moment we've got Gail and Aiden. That's the same combination as Aiden and Gail, isn't it? You're not going to list those two separately because it doesn't depend on the order when we're talking about a combination. So part A says evaluate 5C3. So what this means is we have a group of 5 symbols or 5 people and we're selecting 3. How many possible groups can we have? How many possible groups of 3 can we have from 5 things we're selecting? Now there is a formula for it using factorials. That's this one here. So we could put it in our calculator as 5 factorial on top of 3 factorial multiplied by 5 take 3 factorial. All right, so we could evaluate that in our calculator, but there's a faster way as well. And so what we do in our calculator to bring up C is we press option. All right, we press option. We press the across arrow. We press probability, and you'll see NCR. NCR. And the way we would type it in our calculator is 5, the C, and then the 3, and then press execute. So if we type this in, 5C3, we will get 10. Okay, so verify that that's the case. What that means is if we have 5 things and we're picking a group of 3, we've got 10 possible groups we can have. All right, or in the next example, we have 16 students in a maths class and we're picking the maths squad of 4, okay? We're picking a team of 4 to represent the class. How many possible arrangements are there? Well, we have 16 and we're talking about groups of 4. How many possible groups of 4? 16C4. Put that one in. I've got 1820, 1,820. All right, so you can see there's lots of possible combinations and they get larger and larger the bigger this number is at the front here. All right. So like for instance, say we're going to pick a maths squad from this class. Okay, so we pick Mace, Will, Jolie and Alfredo. That's 4 people. But then you see there's another, so that's one group. There's another group that consists of Mace, Jolie, Will and Francesco. And then there's another group that consists of these 3 and Sam. And so you can see how it compounds. There's every possible rearrangement. And that's why we have 1,820. All right, any questions from these 2 exercises?
What's the utility of the factorial?
Utility of factorial notation.
Yeah.
So we use factorials here, like we learn it here, and then this is the formula that we've got for calculating combinations. So that's the first point. All right. So it's like we understand it and then we're applying it in a formula.
Will I ever use like just a factorial number?
Every day.
Every day?
Every day. Yeah. Especially if you're a maths teacher.
Not yesterday, not tomorrow.
No.